Hello and welcome to the MEIA 2022 Pitch Competition Finale. My name is Brian Toll, and I am MEIA's director and your moderator for today's program. In case you don't know us, MEIA stands for the Maryland Energy Innovation Accelerator. MEIA is an economic development program of the Maryland Clean Energy Center. We focus on accelerating the commercialization of clean energy and climate technologies developed at Maryland-based businesses, universities, and laboratories. Please take a look on your screen for today's program. Now let's begin. Our first speaker today is Chairman of the Board of the Maryland Clean Energy Center, Geoff Oxnam. Geoff is also founder and CEO of American Microgrid Solutions. Welcome, Geoff.
Hey, thanks, Brian. And thank you all for being here today. This, I will admit, is one of my favorite days of the year. I am always amazed and blown away at the technology and originality that comes out of this competition, and it makes it a not to be missed event. The work that MEIA has done to be able to put this together and to help the teams going has really been remarkable. And I want to thank Brian Toll and Ben Margolis for all their hard work, Kathy Magruder and the team at Maryland Clean Energy Center for working on this. This organization started as a pitch, just like you're about to make today, and it's grown into something pretty darn impressive. I want to make sure to thank all of our sponsors today: MCEC, Exelon, the Butts Foundation, Maryland Energy Innovation Institute, the Johns Hopkins Energy Innovation Institute, Johns Hopkins Ralph O'Connor Sustainable Energy Institute, Banner Witkoff, Memphis Brown, Snyder Cone, Whitford Taylor, Preston, and Points North. The sponsors are critical to being able to provide not only the ability to hold an event like this, but also to sustain, direct, and grow these organizations. So thank you very much. Judges, thank you for making the time today. There is always a great deal of thought and energy that goes into assessing the pitches, and to have your leadership is extremely important and valuable to all of us. But most of all, I want to thank the teams today. I want to thank you for your courage and for your vision. I'm an entrepreneur just like you. It's not easy, and my hat is off to you. I'm not nearly as smart as you, but I'm smart enough to go and hire people who are as smart as you are, and to try to build a company, an advanced energy company around that. The money that's at stake today is not going to make the future of your company, but the ability to pitch in front of this group very well could. I know that I've reached out to companies after seeing them in this pitch competition. I know other companies that have reached out as a result of this pitch competition. You are presenting in front of some of the best and the brightest around. I wish you a lot of luck, but know that you have already been successful by having the opportunity to pitch here today. So thank you for being a part of it. Good luck today, and I can't wait to see what happens next. Brian, back to you.
Thank you very much, Geoff. Our next speaker today is James Zahler, Associate Director for Technology to Market at ARPA-e. Welcome, James.
Thank you, Brian. So yeah, I thank you for the opportunity to speak today. I'm a big fan of everything that's going on in Maryland around innovation and energy. We've had a lot of projects out of the University of Maryland and the other schools in Maryland, as well as companies. One of my projects I saw was an alumni winner, Smartwood, from the University of Maryland and Bing Hu's lab. Yeah, so I'm just going to give a quick overview of ARPA-e, what we do. And then we can kind of drill down in terms of how we kind of help entrepreneurs and how we help innovators develop energy technologies. So ARPA-e was founded in 2007 by the America Competes Act. This was based on a National Academy of Sciences report called Rising Above Gathering Storm. We were We were not funded at that time. We were funded for the first time in 2009 under the ARRA, or the Recovery Act, with $400 million. That $400 million was put into a program called OPEN. It was the first large program that was run by ARPA-E. And subsequently, we've run dozens of focused programs, as well as open programs and others. The current fiscal year budget is $450 million. And it has been growing steadily over the last 5 years. And the anticipated, or the requested budget next year is $550 million. Now that obviously goes through a sausage grinder at the at Congress, but we'll see where that comes out. So ARPA-E was based on the investment model from DARPA, and so what that means is that we have the money that we have is fungible. So we are able to operate. We are able to put that money to whatever we see fit, right? So we have program directors that are forming programs. We have tech to market advisors that are helping them with that process. And really, what turns into an ARPA-E program is the ability of a program director to demonstrate that that their technical vision overlaps with our mission. And our mission is three things. It's more than this, but I summarize it in three ways. So it is energy technology leadership, it's energy security, and it is decarbonization and the removal of other emissions associated with the energy industry. So if a technologist can demonstrate that they, or a program director can demonstrate that they have a program idea that will meet those targets, we can do it. And as such, we've run programs from agriculture to generation to transmission to storage, transportation, efficiency, you name it. So we have a very broad mandate and a lot of freedom in terms of how we go and put that into effect. And we have a very hands-on, very proactive management approach to how we work with project teams that are working for us with ARPA-E's funds, which gives a lot of flexibility, especially for entrepreneurial organizations where you do need to pivot and be quite nimble in terms of how you pursue what you pursue. So that's kind of ARPA-E in a nutshell. And so then drilling down one layer. So one of the things that we have within ARPA-E that is a bit unique within the Department of Energy and actually differentiates us from DARPA is the T to M function, which I manage. So the T to M function is designed to support the commercial transition of technologies that come out of the ARPA-E program. Those commercial technologies are, the T to M function kind of works throughout the program lifecycle, framing the program in terms of technical and commercial targets so that the technology, if successful, will matter in the real world. Putting together a set of milestones that help technologists to think through the commercial aspects of their technology as they're working. And then helping with the transition at the back end. And of course, all along the life cycle of a program, we're building a network of interested stakeholders, from investors to industry to suppliers, customers, to make them aware of what we're doing and bring attention to the programs and teams that we're working with. And then on the back end, we do help with the transition to the next phase of development from all the of the teams that are working within our programs. That transition phase can take a couple of different flavors, right? So we can help with introductions to investors and other support functions. We also now have some other tools in our toolbox. One of them is something we call the Tech to Market Fund, which is a way that we can basically support the build out of a team and a business plan around a technology. So this is in recognition of the fact that a lot of the technologies that we support are coming out of national labs, universities, et cetera. Oftentimes they have brilliant technologists, but there may be some needs for entrepreneurial skills that those folks don't necessarily have based on their prior experience. So we use that T to M fund mostly to build teams and to build plans. But that's really done as kind of a precursor to another program that we're running now called Scale Up, which allows us to invest much larger amounts of money into the transition of a technology from the bench scale to the real world. So basically, getting it out of the lab into a prototype that can then be put into the real world, where we can get performance data, reliability. We can start to understand the value proposition in much greater detail through this. And so this is a program that we're actually running right now for the second time, but these are awards that can go up to $20 million. So starting with ARPA-E, you might look at an award of $4 to $5 million on the high side. But working with the DOE, there's an opportunity then, and ARPA-E, there's an opportunity then to grow the access to larger and larger pools of capital as you develop your technology. And of course, it doesn't stop with Scale Up. We now have a program called OCED that's in the larger DOE. It's the Office of Clean Energy Demonstrations. That office is putting to work about $21.5 billion toward demonstrations of various technologies. The money isn't as fungible as it is within ARPA-E, but it is aimed at some pretty major challenges. So hydrogen hubs, carbon capture and sequestration, grid modernization, battery supply chain development, et cetera, just to name a few. And so those guys are going to be making rather large grants to awardees. And then in the hydrogen hubs, they're going to be in the neighborhood of $1 billion. So that would be kind of the next step up the size scale. And then finally, there's the Loan Program Office, which has over $40 billion in funds to be delivered to technologists that are attempting to scale or scaling an actual facility with offtake. And so this is now a loan. This is now a loan that can be used to expand operations against an offtake agreement and collateral. But by offering that service, LPO is able to basically bring things to bankability that might not have otherwise made that transition. So thanks again for your time. That's kind of a very brief overview of ARPA-E and kind of where we sit in the DOE. I wish everybody the best of luck.
Thank you very much, James. It was great to see you and see you at the ARPA-E conference a few weeks ago.
For sure. Thanks a lot.
All right. Our next speaker today is Ben Margolis, Commercialization Manager at MEIA, who'll give an overview. Welcome, Ben.
All right. Thank you, Brian. I'm the Commercialization Manager in addition to managing the slides today, too. So thanks again, Brian. So yeah, for those of you who don't know me, I'm Ben Margolis, the Commercialization Manager here at MEIA. I work with the teams to recruit new members and as a project manager to guide our teams through the different programs. So for those of you who are new to MEIA, the main focus is to support early stage clean energy and climate technology innovations with an ecosystem-based approach. So if you take a look at our slide here, in the middle is the startup teams. They're surrounded by our ecosystem of support. The startup team in this case could be a university professor who invents a new technology and is seeking MEIA's help to form a startup team, investigate applications for the technology, create its first business plan, and launch the company. Alternatively, the startup team might be an established small pre-revenue business that has specific gaps to fill or milestones to achieve that would make that company investable to third-party capital providers. We help them by matching those startup teams with business executives, or as we call them, energy executives in residence, or EEIRs, as I might reference later, highlighted here in the upper left. Our goal is to find very well-qualified people who will consult to the startup team with an eye towards joining that team as a founder or employee at the end of the consulting engagement. We then approach the market for strategic partnerships to support and mentor those teams. Strategic partners are corporations that donate their time and resources towards supporting our teams as they search for product market fit. Startup teams also have access to support from our professional services sponsors, which include the law, accounting, and marketing firms that you'll hear from today. And finally, because everyone is part-time, MEIA provides project management that keeps everyone on task, moving towards specific milestones throughout our different programs. So our different programs we offer three programs to support startup teams at different levels of maturity. For early stage ideas and concepts, we have the Pre-Accelerator Program. This is for TRL level 1 to 3, which, if you're unfamiliar with the scale, is extremely early for technology development. It could simply be an idea or concept to explore within the industry. This program matches technologists and inventors with an industry mentor to explore the market through a process called customer discovery. For early stage technologies, we offer the Launchpad program. This is for TRL 3 to 5, which is still early from a technology development standpoint, but it's at a point where the inventor could potentially create a company. Basically meaning they've had initial proof and technical validation, but need some industry support to get to market. For this program, we recruit potential EEIRs that could serve as CEOs or board members. And we then go through a more extensive customer discovery process and shape out the full business plan. The premise and hope of this program is that the EEIRs and inventors could potentially team up and incorporate and launch the business, thus the Launchpad. For more formed companies and spin-offs that are still early in their development, we offer the Accelerator Program. This is for spin-off companies that have already formed and have a team in place, such as a CEO leading the company. This is a more targeted engagement where we work with the team to identify specific subject areas to grow the company. And then we recruit EEIRs and engage them in a 4 to 6 month project. The purpose is still to get the EEIRs involved in the long term, but the level of involvement could be different. Ultimately, throughout all our different programs, our ecosystem of support leads directly to the creation and acceleration of high-quality Maryland-based businesses that are solving critical problems in the areas of clean energy and climate. And I'll turn it back over to Brian to introduce the judges.
Terrific. Thank you, Ben. It's now time to meet our judges. Each judge, please take a minute to introduce yourself. First, we have Michael Campos from Azola Ventures. Welcome, Michael.
Thanks. So I'm Michael Campos. I'm here representing Azola Ventures, where we invest in climate technology companies with the potential to reduce greenhouse gas emissions at the gigaton scale. We're an impact-first venture capital firm, and we're investing what's called catalytic capital, partly philanthropic dollars, into overlooked, unloved categories in climate. And in fact, we can only invest in companies that would be unlikely to be fully funded but for our participation, but which we believe have a path to large-scale emissions reductions if properly nurtured at the early stage. So our firm is based in Boston, which is where I'm sitting today, but I'm originally from Rockville, Maryland, importantly for this event, and I'm thrilled to be a part of this. So thanks for the invitation, Brian, Ben, and the MEIA team. It's wonderful to be back here. It's great to see some familiar faces, and I'm looking forward to today's pitches.
Thank you very much. Our next judge is Brett Clark from Volo Earth Ventures. Welcome, Brett.
Hello, everyone. Great to be here today. So I lead deal flow for Volo Earth Ventures. Just a little bit about Volo. We're an early stage focused climate tech fund. So that means for us, we primarily invest in pre-seed through Series A, which is really great with this MEIA event. So for us, we look at things that are straight out of the lab all the way up to pre-commercialization. And we just believe that there is really a need to be funding these early stage endeavors that we're looking at today. In terms of our investment theses, one part of it is quantifiable carbon reduction. So we focus on projects and services that really that focus on reducing large amounts of carbon emissions. And the other side is economic merit. We see with this next generation of climate tech innovation, we really think it's going to be able to compete in markets just based solely on unit economics and not being reliant on subsidies or green premiums. And so just excited to looking forward to this event. And thank you, MEIA, for setting this up. Great to meet you all.
Thanks so much, Brett. Next, we have Sean Sinha from Constellation Technology Ventures. I also want to thank Sean and Constellation Technology Ventures for being a MEIA sponsor this year. Welcome, Sean.
Hey, Brian, thank you for that. I'm Sean Sinha. I lead Constellation Technology Ventures, which is the venture investing arm for Constellation Energy. We are a strategic venture investing arm. Constellation Energy's business is generation trading and power marketing across sort of the comparative energy landscape. And as the venture investing function, we look to invest alongside sort of the energy transition and the decarbonization landscape focused on the power utilities, clean tech segments, carbon markets, and electrification of built environment and transport. We typically are Series A plus investors, and alongside looking for sort of financial merits and outcomes from the venture portfolio, we also strive to drive commercialization through our various operating sort of units. We've had 30 plus investments till date with an active portfolio of 12 companies across various stages. Excited to be part of this event, and Brian, Ben, and rest of the MEIA team, thank you for organizing, and looking forward to the rest of the event here.
Great, thank you, Sean. It's time to begin our pitch presentations. In between each presentation, while the judges are filling out their scorecards, we'll take a few minutes to meet our sponsors and supporters. Our first team today is ATP-MD LLC. Please welcome CEO Joe James. Joe, you will have 10 minutes for your presentation and 5 minutes of Q&A with the judges. Please begin.
Climate change is the world's greatest existential threat, but if handled well, it presents one of the world's greatest environmental, economic, and societal opportunities. Using our CRBBP process, we do good things for the health and well-being of the planet and its people. Next slide. Hi, I'm Joe James. I'm a former 33-year economic development professional. I won the Purpose Prize in 2008 for my work using innovative ag-related concepts to uplift poor, rural, and urban communities of color. That laid the groundwork about what I do today. I served a 6-year term as a secretarial appointee on the Federal Biomass Research and Development Technical Advisory Committee. I invented our CRBBP process and invented, licensed, and patented innovative biomass carbonization and utilization processes. Next, please. The challenges that we're focused on are climate change, where there's a need for cost-effective CO2 capture and carbon reuse, other environmental challenges that face air, soil, and water, and particularly in a city like Baltimore, health challenges where dangerous levels of airborne particulate matter and other contaminants are flowing into at-risk communities, causing illness and death. Next, please. Our solution is our combined remediation, biomass, and bioproduct production process. Using that process, we plant and we multitask. The multitask is important because it allows us to make things in a much more cost-effective way. We're multitasking special biocrops to capture CO2, simultaneously remediate contaminated air, soil, and water, and they do that less expensively. We then harvest and convert those crops into circular economy bioproducts in which the captured carbon is sequestered. Next, please. Our favorite crop is biomass sorghum because it grows fast, big, and in 6 months captures 7 tons of CO2 per acre. You can see on the left standard sorghum. Well, it was on the left, and it is again. And on the right is biomass sorghum. You can see they're both at their 6-month maturity, and you can see the differential in size. Next, please. We asked the University of California at Berkeley to do an assessment of the CO2 capture rate for biomass sorghum, switchgrass, and pine trees, and you can see how excellent biomass sorghum compares to those other sources, other mechanisms for capturing CO2. In fact, we hope the federal government will do an analysis of the uptake potential of key crops and trees and do a comparison like we've done here. Next, please. So our target customers and markets are the following. For environmental services, we've targeted utilities. And then we make a variety of bioproducts, including a bio-based filler powder alternative to carbon black. We also make a superior poultry house bedding, and then we can then convert that litter into a biochar soil amendment as well. Next, please. Our utilities go-to-market strategy has got us first involved with the Exelon Corporation. ATP-MD received funding from the Exelon Corporation to begin a project in Baltimore. We have then been acquainted with Dominion Energy, who's providing funding for us to do a project in Ohio. And then lastly, Philadelphia Gas Works has also engaged us to do a project in Philadelphia. Next, please. Oh, before we leave that, yeah, that's good. That's good. Next slide, please. So with these utilities, we're carrying out several utility demo projects, which involve planting biomass sorghum in their sites to capture significant amounts of CO2. And then we collect the biomass and convert it into biochar, which is then applied to those sites to permanently sequester the captured carbon and generate carbon credits. Actually, our first project will be this spring, beginning in Ohio, and we hope to be planting in both Baltimore and Philadelphia next spring. Next, please. We're also working on a concept of bringing farms proximate to large emitters. And we do that through a concept that we're still working on called vertical biocrop farms. And because we're able to take a crop that has a single 6-month outdoor season and create 2 indoor seasons in perfect light and environment, we think we can dramatically increase our CO2 capture rate. Next, please. So our VBFs should be able to capture CO2, up to 20 tons of CO2 per acre per year from power plants and other large CO2 emitters, including emitters like the harbor tunnels. Next, please. So as our biocrops remediate vacant sites in cities, they'll capture CO2, and given the size and leaf structure of our crops, they can also screen out significant amounts of airborne particulate matter. They will also do the same as they remediate utility sites or brownfield sites, or extract excess nutrients from the soils of watersheds like we've done for the Chesapeake Bay watershed. Next, please. Again, we convert the resulting biomass into a variety of circular economy bioproducts. Next slide, please. Here's an example of a shipping pallet made from plastic waste blended with our bio-based filler powder. The USDA helped us make that pallet. Next, please. We've accomplished several milestones. We've successfully demonstrated our ability to extract nitrogen and phosphorus from Chesapeake Bay watershed farm soils. We've successfully demonstrated the efficacy of our cost advantage bioproducts. I mentioned ATP's funding from the Exelon Foundation. Our Virginia operating affiliate was assisted by Dominion Energy, and our Pennsylvania affiliate is involved now with Philadelphia Gas Works, as I mentioned earlier. Next, please. We have an outstanding group of collaborators, R&D partners, and funders. We also won the Lake Erie Hack Competition Prize for work that we're going to do in Ohio that also protects Lake Erie, similar to the Chesapeake Bay. We are among the first grantees of a new federal program called BioMade, and in collaboration with the University of Akron School of Polymer Science, we're demonstrating the efficacy of our bio-based filler powders. We've got great university partnerships doing a variety of different things. We're excited about some things that are in the future coming up in collaboration with those universities as well. Next, please. There are major risks, of course. There are technology risks, and competitors might be able to find better ways and less costly ways of doing what we do. However, our ability to capture CO2 right now costs about $50 a ton, which is very competitive with what the other alternatives are. And our multitasking feature helps to mitigate that technology risk. And there certainly are governmental incentive risks. We're disappointed that most of the incentives are directed at other forms of carbon capture. We think that the ability for certain types of biocrops to capture lots of CO2 deserves support from the federal government as well. Next, please. We certainly have competitors. Some are using equipment to capture CO2. Others have floating islands that clean up water-based challenges. Conza Renewable Fuels uses carbonization to make bioproducts, but we're not aware of any companies that are able to utilize more than one or maybe two of our patented 4 solutions under our CRBBP process. Next, please. So when we look at where we'll be in year 2030, we think we can capture about 8,300,000 tons of CO2 over the various acreage treatments that are listed here in this chart. And we're excited about the multi-state efforts that we're involved in now that are going to get us heading in that right direction. Next slide, please. So if we do this right, our nation and the world avoids the perils of climate change. Utilities lessen their carbon footprint. Manufacturers enjoy cost-effective bio-based inputs like our filler powder. By the way, carbon black is pretty nasty stuff. I don't know if you've looked at how it's made and what its impact is. And we are becoming more and more concerned about something called tire wear, where every 3 years or so, you have to replace your tires. Well, they sort of wear out and they create a powder that gets into air, soil, and water. We're concerned about that, and our product can help overcome that challenge. Our nation and states will benefit from a new bioeconomy. We're very excited about our relationship with BioMade, and in fact, they're coming out with a new solicitation focused on climate change. We look forward to getting involved in that. And dear to my heart, we can do things that provide environmental justice, better health outcomes, and jobs, and other economic benefits to at-risk communities. Next slide, please. So again, climate change is the world's greatest environmental threat, but if handled well, it presents one of the world's greatest environmental, economic, and societal opportunities. Using our CRBBP process, we do good things for the health and well-being of the planet and its people. Thank you.
Thank you very much, Joe, and right on time. For the Q&A, we will go in our sort of a round robin format. So I'll ask Michael to start off with questions.
Sure. Hi, Joe. It's good to see you again. My first question is, could you walk us through the mass flow of where soil contaminants end up? You mentioned that the biomass sorghum uptakes nitrogen, phosphorus, but ultimately, where do you see those ending up? And do you manage contaminants beyond nitrogen and phosphorus?
Well, it depends on where they're applied as an end product. So if we're going to make a filler powder, they're not going to have much impact for that use. If we're making a biochar soil amendment, we'd want that soil amendment to be used in places where there's not a concern about nitrogen and phosphorus and watershed soils. But the last thing I will say is that given work that we've done years ago with the Electric Power Research Institute, we have some colleagues that have aqueous leaching processes designed to treat biomass and to pull out problematic substances and be able to sequester them to make sure they're not getting into the wrong place. So we have some options in terms of how we could treat nitrogen, phosphorus, but more importantly, we also want to use our process on brownfield sites. A city like Baltimore has lots of old industrial areas that are contaminated through industrial activity in the past. And using this leaching process, we can end up with a feedstock that has been cleaned to a point where it's not going to be a problem.
Brett, would you like to go next?
Yeah, thank you, Joe. I really appreciate your presentation. I was just curious, do you have any comparisons on the water usage of your organic carbon capture versus others in the space right now?
We use about the same amount of water as corn does. Our crops just grow a lot faster. So it's not, there's no excessive water requirement for our crops. In fact, sorghum is one of the world's oldest food crops. As you can see, it normally would have a large seed head. Biomass sorghum was bred to make cellulosic ethanol. They wanted to maximize the amount of plant material per acre, and that's what that crop accomplishes.
Thanks, appreciate that. Thank you.
Sean?
Hi, Joe. Nice, good to see you again. Can you speak to sort of the efficacy of the carbon capture on sort of a per unit of land use basis as opposed to sort of your competitors, and how do you really sort of drive that value proposition given that the land use component here could be substantial, and as compared to other forms of, say, direct carbon capture?
Well, number one, given the velocity at which the plant grows and the size that it gets to in 6 months, you've seen the chart that shows it's by far an extraordinary CO2 capture organism. In fact, our cost of growing it per acre is around $50, maybe $60 a ton. And if you simply use that for the cost of capturing CO2, it would be it's a very efficient process already. There are many applications in addition to brownfield sites and other sites. As I was driving to our BioMade annual meeting last week, I passed through a a wind farm that was so large. It was in northern Indiana. I was on the high interstate, and it took me 15 minutes to get through it. But I noticed that it was sort of built in a farmed area, and there were plants below it, but there were small plants. So we've had a dialogue with the operator of that site, indicating that we think that if a 20-foot high plant was to grow on that site, there will be times during the year where we could substantially increase the amount of wind up against the blades and increase electric production on those sites. In addition, we could, as we have done with the utilities, we could harvest the crop, convert it into biochar, put it in the site, and generate carbon credits for that activity. So there's a number of ways that we are able to treat different sites and maximize the value proposition for the site owners.
All right, that's our time for today. Thank you so much, Joe. Great work.
Thank you.
MEIA and our participating teams are supported by sponsors that provide both financial and in-kind support. I want to thank our sponsors and supporters and give you a chance to meet them. First, let's meet Teresa Christian from Exelon. Welcome, Teresa.
Thank you, Brian. It's a pleasure to be here. For those who are not familiar, Exelon is an energy delivery company. We have operations in the Mid-Atlantic and Midwest US, serving 10 million customers with electricity and natural gas. And because we're local here in Maryland, serving folks all the way between DC, Baltimore, and many rural parts of Maryland as well, it's a pleasure in particular for us to be engaged with the MEIA group and with the innovators represented here today. So really appreciate your championship and your creativity addressing the challenges that we're all facing. For Exelon, some of the challenges that we think about include operating the grid efficiently, reliably, and with a decarbonized mix to serve our customers and communities into the future. And then also, how do we deliver fuels and use the broader components of the economy in a way that's going to serve our collective societal needs and continue to provide that energy that powers the economy. So really excited to be partnering with some of our local friends here in Maryland, and hope to meet all of you another time soon. Thanks, Brian.
Thank you very much. Yeah, thank you. Now I'd like to introduce Kathy O'Brien Stevens from the Maryland Energy Innovation Institute. Welcome, Kathy.
Hi, Brian. Thanks for having me. Dr. Eric Waxman, who is the director of the Maryland Energy Innovation Institute, sends his apologies, but he's got several other meetings going on. So my name is Kathy Stevens. I'm the research director for MEI Squared, as we like to call it. MEI Squared became an institute in 2017, thanks to Governor Hogan and the state legislature, who charged us with collaborating with all academic institutions across the state to participate in clean energy programs and to help develop and attract private investment in the clean energy innovation space. Prior to MEI Squared being formed, there was really no Maryland-focused early stage energy investment until us, which was surprising since Maryland actually spent over $400 million a year on energy-related programs, but none of these were authorized to support in-state development of clean energy firms. So along with MCEC, who is our partners, and MEIA, we're very happy to be going forward with this. Since its creation in 2017, MEI Squared has helped obtain $79 million in federal funding for the state of Maryland's economy. And we've provided a 33 times rate of return on Maryland's investment. So we're very happy about this. Large part of this is due to the seed grants that we offer every year. For the past 5 years, we've offered $400K in seed grants. We usually award 4 to 6 of these. And the goal of these seed grants is to bridge the gap between transformative academic research and prototypes or processes to obtain investor interest through technology development, creation, and the advancement of university startup companies within the state. So any full-time tenured or tenure-track faculty members at any Maryland state academic institution or Maryland companies that are affiliated with these academic institutions are eligible to apply. And the goal of these seed grants is to advance energy, technology, and economic growth in the state of Maryland. So it's been an exciting time. We've awarded 22 seed grants so far. As I said, it's generally been $400K a year, but I'm happy to say that going forward, starting with fiscal year 23, we're actually going to have $650K to award in these seed grants. So thank you for having me today, and we look forward to continuing our partnership.
Thank you, Kathy. Our second team today is CUPtech. Please welcome CEO Steve Goff. Steve, you have 10 minutes for your presentation and 5 minutes of Q&A with the judges. Please begin.
Thank you, Brian. Today I want to introduce you to our new company, CUPtech, and an exciting new technology we are developing for the catalytic upcycling of mixed plastic waste into new products, new plastics and consumer products that we use every day. Next slide, please. Today there is a significant and increasing problem with inadequate supply of recycled material for new plastics. Most of us are familiar with that the management of plastics, waste plastics, presents a global problem. The volumes are massive. In 2020, we consumed 17 million tons of plastics in the US, and effective technologies for recycling those plastics do not exist. If you look at the table on the right, it shows a list of your typical or major product plastic types. On the far right it shows that only a few of these plastics are actually recyclable. The US Plastics Pact, which is a consortium of more than 60 major companies, government entities, NGOs, and other stakeholders, have set significant recycling targets to achieve by 2025, just 3 years from now. One is that 100% of plastic packaging will be reusable, recyclable, or compostable. As of 2022, only 37% meets this criteria. A second is to achieve 30% recycled content in new plastics. Again, as of this year, only 7% of plastic content is recycled. So there are huge gaps between the demand for this recycled content and supply. With the CUPtech process, all waste plastic types will be 100% recyclable. Next slide, please. So the CUPtech solution involves a catalytic conversion of waste plastics into valuable chemical products. It was developed at Johns Hopkins University by Professor Chao Wang under a DOE ARPA-e grant, which led to IP on the catalyst formulation and hydrocracker reactor design. What makes it very unique, it is highly selective for the production of high-value aromatic products, which includes benzene, toluene, and xylene, commonly known as BTX. And it's key that the process can accept any mix of waste plastic feedstock. Next slide, please. This shows a schematic of the CUPtech process. The core of the process is the hydrocracker in the lower right corner. This is a technology commonly used in the refining industry, but will involve a proprietary catalyst for the CUPtech process. Based on lab scale testing, it achieves a very high conversion of the carbon content of the plastic, greater than 99%. It is also very selective for the production of the BTX products, 50 to 80%. The BTX price as of 2020 was $1,200 per ton, creating a very high value proposition for this process. Also, preliminary economics based on Aspen Plus modeling shows a 50 to 75% profit margin. Next slide, please. Now, if you're not familiar with BTX, benzene, toluene, and xylene, they represent three of the five largest global petrochemicals. Looking at to the right, you can see that they go into the production of many common products we use every day. Benzene is used for the production of polystyrene and nylon. Toluene goes into polyurethane, and xylene goes into production of PET. Many large consumer brands are looking for recycled content to produce PET, creating a great opportunity for this new process. It's also important to know that the BTX from the CUPtech process is chemically identical to traditional BTX. So with BTX as a product, CUPtech creates a high value proposition comparable to other product technologies being developed, which tend to be based on thermal pyrolysis that produces a fuel or naphtha product. Next slide, please. Now, looking more at the competition, this slide shows on the horizontal axis increasing feed flexibility from processes that require a separate waste plastic feed on the left to processes that can accept mixed waste plastics as you move to the right. On the vertical axis is increasing product value from a relatively low product value at the bottom, increasing to a higher product value at the top. Looking at the lower right, the majority of mechanical recycling falls in the lower right since it has low recoveries and only can target a few plastic types. As you move to the lower right quadrant, there are a variety of processes being developed today. Again, tend to be based on thermal pyrolysis that produces a fuel oil or fuel type product or naphtha product, which has a relatively low value and tends to be consumed for combustion and energy production, or requires significant further processing to produce chemical feedstocks. In the upper left quadrant, there are a few processes entering the market that produce a higher value plastics product, but require a separate waste feedstock. So they require pre-processing of the waste feedstock into the process. CUPtech in the upper right can accept mixed waste plastics and produces a high value BTX product. Next slide, please. This slide shows our development status and plan. In 2021, batch laboratory tests were completed that led to the invention of the process and establishing IP. Earlier this year, upgrades to the laboratory apparatus enable continuous flow at a 1 to 10 kilogram per day capacity, and we've completed extended multi-day runs that have led to further optimization of the process. As we move into the fall of this year, we will be kicking off design work for a pilot plant of a capacity of 1 ton per day, which we are planning to construct and start up in 2023. Then as we move further out, we will be looking to design and construct a larger demonstration scale plant on the order of 10 tons per day. Next slide, please. Our business model and commercialization plan really involves us partnering with an industry leader to site, construct, and operate this 1 ton per day pilot. We're talking with a broad spectrum of companies, including waste companies, petrochemical companies, catalyst suppliers, and your major consumer brands. Our go-to-market strategy is then to identify a beachhead market, examples being a major brand or a PET manufacturer, form joint ventures then to develop, construct, own, and operate these facilities, with CUPtech providing the catalyst materials to the process or to the facility, along with hydrocracker design and ongoing maintenance services. So in addition to licensing the process, CUPtech's business model will involve the sale of the proprietary catalyst, hydrocracker, and as I say, hydrocracker reactor design, engineering information, and ongoing maintenance services for the catalyst and the hydrocracker reactor. In addition to myself, our team consists of Professor Chao Wang, the inventor of the process at Johns Hopkins University. We also have 2 advisors, Larry Black, a former or retired executive from Waste Management, and Bob Gaddy, a retired executive from Grace. A little bit more background on myself. I have a 35 plus year career in waste energy. I was responsible for R&D at Covanta for many years. In that role, I looked at many processes involved targeting the recycling of waste plastics. They tended to be based on thermal pyrolysis and produce a lower value fuel product that also had questionable sustainability since they ultimately would be often used for fuel, a non-renewable fuel for energy production. What attracted me to CUPtech was the basis of the process is catalytic and selectively producing a higher value product, BTX, which goes directly back into producing consumer products and new plastics. Next slide, please, Ben. So finally, our ask, CUPtech is looking to raise $1 million in pre-seed money for 24 months. We'll be using these funds to find a partner, to host a pilot facility, which will be, and support our grant, our application to the DOE, which will provide the majority of the funding for that pilot. We'll also be at the same time advancing engineering on our hydrocracker design and scale up and trying to refine the commercial system design and economics. And finally, we'll be looking to build our team, focusing on operations and business finance expertise, and also secure the IP license from Johns Hopkins University. So this concludes my presentation, and thank you for your attention.
Terrific, Steve. Thank you so much. We're going to move to questions, and Michael, I'll ask you to open it up.
Okay. Thanks for a nice presentation, Steve. So my question is, so a while back, a teammate and I here at Zola took a look at plastic-related emissions and found that much of it was actually upstream of making the plastic. It was in ethylene refining. And I wonder to what extent this technology is similar or different. So could you comment on life cycle emissions in this process?
The ultimate, we're still refining, and I need to spend more time on the overall process flow diagram. But this process will have very low emissions of greenhouse gases, if you will. Non-selective products, for the most part, will be recovered and recycled back for the production of BTX. There will be some lighter hydrocarbons that are produced, which will be non-recyclable and will be consumed to provide the fuel needs of the process. The specific energy balance we still need to refine, but those non-selective product, light hydrocarbons, will be combusted to provide energy, will lead to some CO2 emissions. You mentioned ethylene and propylene. They are the other two largest petrochemicals globally, and are them along with BTX are really the chemical building blocks of what we as society consume every day. So all the BTX produced by CUPtech will be backing out petroleum-based BTX, which would be a very positive, move towards a circular economy.
Thanks very much.
Brett.
Steve, thank you for the presentation. I really appreciate it. From my limited understanding of the space, I know that one of the issues is the purity level of the recyclables input into the machinery like this. So I was hoping you could unpack a little bit of what purity level is necessary of the recyclables for a successful process, and just would love to understand that side of things a little bit more.
We are still evaluating all the potential contaminants, the catalyst. Impurities will have an impact on catalyst life and the activation of the catalyst. The catalyst is regenerable for the most part, so we will be able to address that. But early testing shows that common impurities in your mixed waste plastics, and Professor Wang is working with real waste plastics, collected at the university. So your basic impurities of different mixtures and films, or just some dirt or what have you on the plastics as they go into the process, is not an issue. Your typical contaminants for catalysts, things like sulfur and chlorine, would have to be. We're still trying to define that impact on catalyst life, but early indications are it will not be a significant problem that we will manage as part of the process design.
Awesome, appreciate that.
Sean.
Yep. Steve, thanks for the presentation. Sort of a a two-part question focused on sort of the economics of this. So it seems like BTX is a fairly competitive segment, and you have scalable existing pathways to create it. So if you could sort of expand on sort of the near-term trajectory of the company to beyond sort of a pilot plant capacity, how do you envision the technology competing on an economic basis? Do you sort of require further policy or regulatory support, like extended producer responsibilities like you have in Europe, or of that kind to sort of help enable sort of a support from an economic basis, ultimately to drive the product to compete with existing platforms?
Really, as I showed in one of the earlier slides, we see a tremendous value proposition here. The cost of waste plastics is an evolving dynamic. Currently, waste plastics are non-recyclable plastics are available almost for free, or actually have a negative value because the producers have to dispose of them ultimately in landfills. We see that value cost of the feedstock evolving as we cite and develop projects and look for long-term supply contracts. We're expecting a cost for those waste plastics that the producers, municipalities, etc., will look to get a value out of that. So we're pricing that into our preliminary economics, but that's far below the value proposition of the BTX sales. And BTX, like all fuel products today, petrochemical, petroleum-based products, are increasing in value. So we see it as not requiring any type of incentives or government type of incentives to drive this technology. It is we see it as a very profitable process. Am I addressing your question with it?
Yes, yeah. Thank you.
All right.
Again, relative to some of the competition, producing more of a fuel or a diesel or even a naphtha product, they have obviously more fuel-based value, which is far below BTX, as well as a sustainability question of ultimately where does that product go to? Does it go to energy production as a non-renewable fuel, or will it go back into petrochemical production?
Thank you, Steve. Great work today. We're going to move on to our next section and introduce Benjamin Link from the Ralph O'Connor Sustainable Energy Institute at Johns Hopkins University. Welcome, Ben.
Thank you very much, Brian. Appreciate that. Great listening to the pitches that we've heard so far. Quick shout out to my colleague and co-conspirator, Chao Wang, whose company we just heard about. It's nice to see him on this call. So the Ralph O'Connor Sustainable Energy Institute was founded about 1 year ago at Johns Hopkins University with a founding gift from the O'Connor family. We are focused on 4 areas of the sustainable energy transition, and those are carbon, grid, wind, and energy storage. And so we have a portfolio of mostly early stage technology development projects, but part of our goal at the Institute is to push the development pipeline a little bit further down towards translation. And so we are fundamentally, our mission is to take the innovations and technology developments from faculty across the university and translate them into useful and commercial applications as we transition to a carbon light society.
Terrific. Thank you, Ben. I'd like to now introduce Gary Fedorochko from the intellectual property law firm Banner Witkoff. Welcome, Gary.
Thank you, Brian. I'm Gary Fedorochko. Next to me is my colleague, Mike Cuviello. Our firm is a nationally recognized full-service IP law firm with over 120 attorneys that has been around for over 100 years. Our primary areas of practice include procurement, enforcement, and management of IP rights, and strategic counseling. We represent clients ranging from startups to Fortune 50 companies. Recent accolades our firm has received: we were recognized as a top IP law firm by Chambers and Partners. Also, our firm received a Tier 1 ranking in IP litigation and patent law from US News.
Yeah, we'd like to, first we'd like to congratulate all the teams for reaching today's finale. We have been
Mike, I can't hear you very well.
Sorry, is this better?
Better, yeah.
Yeah, sorry. So first I wanted to congratulate the teams for reaching today's finale. We've been MEIA sponsors since its inception, and have assisted teams in areas including patent portfolio analysis, licensing, due diligence, right to use, and trademarks. We have continued to represent teams that have graduated from MEIA, and we're available to provide the current teams with IP counseling as needed. Finally, we'd like to thank MEIA for allowing us to participate. We really think the program is important, and we're enthusiastic supporters. And that's it.
Thank you.
Thank you very much. It's great to see you guys.
You too, Brian.
All right, our third team today is Dynami. Please welcome CEO Sergio Barron. Sergio, you will have 10 minutes for your presentation and 5 minutes of Q&A with the judges. Please begin.
Thank you, Brian. Hi, Dynami Battery Corp is enabling the next generation of batteries by electrode microstructuring, because new chemistries is not enough, and battery cells need engineering to fulfill the promise of a decarbonized world. Next, please. I can speak of the opportunity as $1 trillion market, or I can tell you that the European Commission banned internal combustion engines from 2035 but there's something that is much bigger than that. There's only once in a lifetime that internal combustion engine cars will turn into battery-powered electric cars, and that time is now. So all the rest of the arguments are very small compared to the market opportunity we have today. Next, please. What is the problem? The problem is that, no, previous one. The problem is that the batteries are made using obsolete equipment, and there's lack of further engineering, and the equipment used to use these batteries, especially the electrodes, it's almost 100 years old. So it's not well suited for engineered electrodes that have microstructures. Next, please. And that leads into the problem that batteries with no sophisticated engineering lack fast charging. And fast charging is very important for electric vehicle adoption because it mitigates charger congestion, and most importantly, range anxiety, which is one of the big showstoppers in the EV industry. Next, please. Our solution is that we have developed a manufacturing technology, an additive manufacturing technology that creates microstructure battery electrodes, and we have patented that. Next, please. Our technology leverages self-assembly and self-segregation at the microscale to form honeycomb-shaped electrodes that introduce something that is well known for the battery science community, which is secondary pore networks. We have filed patents for this technology in February this year. Next, please. Here you see a scanning electron microscopy image of our electrode. As you see, these are about 70 microns in diameter. That's about half the size of a human hair. And on the right, you see how the honeycombs implement secondary pore networks, which are similar to to lithium-ion highways. That is, the lithium ions can go faster through these less dense areas, making batteries that charge faster and also have higher power. That is without changing anything related to the chemistry nor the architecture of the battery. Next, please. We are in the process of integrating these electrodes, both in our laboratory and using third-party laboratories like Spectra Power. Next, please. The important thing about our technology, our fabrication technology, is that it's a drop-in solution into current production lines. The only thing that has to be changed for any battery cell manufacturer or car manufacturer to introduce to produce a battery that has faster charging using Dynami technology, they have to change the coating of the electrode. And a side effect of this is reducing the electrode manufacturing technology, the electrode manufacturing cost by 80%, because we use infrared drying, which is what is the single most energy consuming part of the electrode manufacturing. Next, please. We have a competition, but we feel that our technology, and we have studied that our technology has some attributes that our competitors don't. Most importantly is that we are chemistry agnostic. That is, our technology works with today's lithium-ion battery cells, like the ones with liquid electrolyte, but it also works with solid states. It also works with metallic lithium anodes and many others. And that's an important advantage. Next, please. Our go-to-market strategy is providing electrodes to battery or EV manufacturers. We can both cater current generation manufacturers, like the ones on the left, but also next generation manufacturers, like the one on the right. That is because our additive manufacturing technology is compatible with most substrates, that is current collectors, the thing where the electrode is coated, and hence being able to adapt to all these technologies. Next, please. This is the type of profit we expect out of the commercialization of our technology. And the important part here is that since we make cathodes and anodes, but most importantly cathodes contain about 50% of the total material cost of the battery, which is the total cost of the battery, that is in raw materials. That gives us a big opportunity to add value to those raw materials and hence have a high profit. Next, please. This is our growth plan. We are in an integration plan, in an integration step. We are 70% there. And for that, we opened a 1 million seed round, which is 62% raised. And the activities of the use of this fund is for third-party integration that we are doing at Spectra Power in California. IP protection, we file patents in the US and most of the world, and establishing a Maryland laboratory. Today, Dynami Battery Corp has a laboratory in Buenos Aires, Argentina. Dynami is a Delaware corporation, but we are working on opening our laboratory in Maryland. And also about this, we are also applying to. We have teamed up with Outreach National Labs to apply to an ARPA-e fund opportunity. So we feel like this is a way to leverage the resources we have today. Next, please. is our team. Is composed mainly of engineers and Professor Brent Goldfeld from University of Maryland, and most importantly, John Law. That is it's an MEIA executive in residence that now is part of Dynami's team, and he's working hand to hand with us. So thank you for your attention, and any questions you have, we are open for you.
Great, thank you, Sergio. Michael, let's get started.
All right. Thanks for a nice presentation, Sergio. It's good to see you again. Early on, I believe you mentioned this could reduce the cost of electrode manufacturing by about 80%, which seems like a big deal. Can you comment on how that factors into the overall battery and the ultimate cost of energy storage, and how customers would receive that information?
That's a very good question. It's 80% of the electrode manufacturing. The total manufacturing cost in a battery cell is about the 12% of the cost of the cell. So that 80% comes out of the 12%. But the important part of this is that, yes, we are reducing, the important part of this, we are reducing money, we are reducing dollars there, but most importantly, we are reducing a lot of kilowatts, megawatts that are used for the battery manufacturing. So it's not only an economic issue, but it's also an ecological issue. And how do we do this? We use infrared flash drying, while standard electrode manufacturing uses football-size convection ovens. Football field size, like huge, like 100 meters long.
Great. Brett, do you have a question?
Yeah. Hey, Sergio, great seeing you again.
Hey, Brett.
Hey, I just was curious about the quality and consistency of the electrodes manufactured through your printing process, comparative to those produced in traditional methods right now.
That's also a very good question. We as you know, we are working at the laboratory level. We get very uniform results, because we use high precision, digitally controlled industrial inkjet printers to do this. But most importantly, there's something that compares well to the traditional electrode manufacturing, which is again the infrared flash drying. Most of the problems with electrodes made traditionally comes from the drying process. That creates uneven porosity on the coated electrode. Our technology creates perfect porosity and super even porosity in all the plane, and that's very important to have better distribution of electrolyte, and that avoids that some parts of the battery cells gets dry during the operation, and that's one of the main failure mechanism of lithium-ion batteries.
Sean.
Hi, Sergio. Thanks for the presentation. Just a more clarifying question. I'm curious to understand if the applicability here for reduced capacity degradation on sort of using the printed honeycomb electrodes, is that largely for lithium ion or solid state batteries as well? And you'd sort of mentioned sort of the EV market as sort of a likely addressable market for this. Are you guys taking the view that ultimately that market also thrives on solid state batteries and moves on from lithium ion technology?
An acceleration. Solid state batteries are lithium ion batteries, but it's a jargon problem. Our technology is a manufacturing technology for the electrodes. So any electrode that is made out of a powder can be made up with our manufacturing technology. creating these honeycombs. About the durability, this is honeycomb shape. This is among the strongest mechanical structures in nature. So we don't claim this yet, but we expect longer cycle life that when compared to amorphous blade casted electrodes because of the mechanical integrity.
Okay, that's helpful. And have you sort of gotten sort of accelerated lab testing results, which sort of shows you proof points relative to for faster charging or reduced degradation?
We are working on that as we speak. This is if you want to the slide and growth plan shows that. I mean, yes, we started a few months ago and we work on that. Regarding accelerated, there's not such thing as accelerated aging in batteries. You can do very little about that, but there's a lot of tests that gives you a hint on durability and capacity fading, and we are starting to get good results.
Okay, thank you.
All right, we're out of time. Thank you, Sergio, very much. Great presentation.
Thank you.
So while the judges are doing their scorecards, I would like to introduce George Nemphos from the law firm Nemphos Brow. Welcome, George.
Good afternoon, and thank you. Thank you very much, Brian. It's good to be here today. We're very proud and honored to be a part of this and be a sponsor. We think the world of the organization and all those that come through it. We actually work with a few graduates and a few individuals in the program. Nemphos Brow is a boutique corporate law firm, corporate and business actually, representing startups through their life cycle and growth, and either to their sale or continuing on or whatnot. You know, we're rather agnostic in industries due to our background. The firm is comprised of all former big law firms throughout the world. We do transactional and general corporate and business advice work throughout the United States with a penchant for the region, if you will. We love to work with startups and entrepreneurs. Most of our clientele, if not all of our clientele, have some sort of entrepreneurial aspect to them, be it an individual, a leader, a founder, or the organization itself. We are founder focused for the most part, and we work very hard to make our clients realize that we believe that they are our business partner as much as we are their advisor. So again, thank you very much for allowing us to be a part of this today. And we have really enjoyed and continue to enjoy, and I'm sure we will continue to enjoy, our relationship with MEIA and the various participants and companies.
Thank you very much, George. I would now like to introduce Jessica Watson from the marketing solutions provider Points North Studio. Welcome, Jessica.
Hey, Brian, thank you so much for the intro. And just a quick congratulations to all the teams that are presenting. We've been a sponsor of MEIA since inception. At Points North, we believe that good design can change the world. So we are constantly challenging the status quo by creating experiences that bring people, passions, and causes together. We do that with exceptional brands, websites, and stories. With over a decade of experience working in branding and marketing for diverse companies and global foundations, we know what drives brand loyalty and conversions. Believe it or not, it's not about jumping on the latest bandwagon or trend, but it's about the passion you have for your work and how well you connect with the people and industries that you serve. Our clients include the United Nations Population Reference Bureau, Giving Tuesday, Plastic Solutions Fund, AARP, even though I claim I'm still not old enough to be a part of that club quite just yet, University of Maryland, Walden University, and tech companies like Zoetech Partners, Andros, Innovation Works, and Upsurge Baltimore. We work with some of the cohorts of the MEIA program to help them develop strong branding, marketing materials, and pitch decks for this very event. We value inclusive messaging, modern design, and accessibility in everything that we do. And our motto is always strategy first and then design. It is a pleasure to be a sponsor. We thank you for the opportunity and for letting us help these teams go north. Thank you.
Thank you, Jessica. Our final team today is EDAC Labs. Welcome, CEO James Zahler. Jim, you have 10 minutes for your presentation and 5 minutes for Q&A with the judges. Please begin.
Thank you. Thank you all, and particularly thank you to Brian and Ben for doing such a great job of running the accelerator. I'm extremely excited to present to you all EDAC Labs, electrochemical direct air capture of CO2. We've developed a pathway to truly scalable atmospheric CO2 removal that's electrically driven, interruptible, energy efficient, inexpensive to build and operate, and closed loop. Electricity and air in, CO2 for sequestration or use out. Slide. I've been involved in the DAC space since 2013, when us crazies could fit in a small conference room and did, continually searching for an approach to direct air capture that could truly scale. I've started $1 billion worth of hard tech electrical and chemical companies, so I think I have some clue what's scalable and what isn't. So I'm particularly thrilled that we're launching EDAC Labs based on development, and Chao Wang, who you just heard about at Johns Hopkins. We've been working through the accelerator for the last 8 months with Professor Chao to refine his technology and create a continuously operating capture system. The technology has been under development for 2 years, and that technology builds on Professor Chao's expertise in electrocatalysis and chemical engineering. Well, this page only has room for the two of us. We have a highly qualified COO and senior scientists waiting to hop on board as part of our launch. We've had extensive discussions with potential collaborators on scaling the engineering and development of large air contactors, which are a critical part of our solution. Slide. So why DAC? I think you've all heard about the Paris Accords, IPCC reports. You've probably seen this kind of graph showing the need for massive scale active CO2 removal to hit carbon neutral by 2050, whether it's tens of thousands of metric tons per annum or billions of tons or gigatons, it's all the same. By 2050, we'll have put at least 2,000 billion tons, it's 2,000 gigatons of CO2 into the biosphere. Unless we actively remove CO2, we can't stop the Earth from warming. Well after 2100, which you always hear about as a date, even if we stop adding CO2 tomorrow, the average residence time of CO2 in the atmosphere is 100,000 years. And it doesn't matter if it went in 100 years ago or tomorrow, it keeps warming the planet. It's not like pollution that washes out with the rain. We have to actively remove it, and DAC is the most scalable of those technologies. Just to give you a perspective of the scale of this whole problem and the opportunity, a single gigaton of coal, which is largely carbon, would occupy the Washington Mall from the Jefferson Memorial to the Capitol to the height of the Washington Monument. Actually 10 times the height of the monument for a single gigaton. So just as the problem and the opportunity are massive, so are the physical resources have to go into solving it. And that's why I think our approach is so critical. Next slide. You know, our technology is deceptively simple. We apply electricity in an electrodialysis cell to separate the ions of table salt and water. That creates an acid and a base. Electrodialysis is a well-established industrial technology used in other purposes in the food and pharmaceutical industries. It has a solid supply chain. You can buy the membranes off the shelf. We don't have to create them. This basic solution runs through a specialized air contactor where it absorbs CO2. That bases aggressively absorb CO2 has been known since the dawn of chemistry. But our air contactor allows molecules in the air, particularly the CO2, to diffuse into the liquid, but not the liquid to mix with the airstream. By avoiding the direct mixing, our active solution doesn't get contaminated with debris in the air, and we minimize water losses. We then combine the salt and the acid in a reactor. This releases the CO2, it reforms the salt, and back it goes into electrochemical cell in a continuous closed loop. As I said, it's deceptively simple, but it's not so easy to get a balance. And there, yes, there is a trick in here that we're hiding until we finalize our IP for it. So why is this such a big deal, and how does it differentiate? Well, I think we've solved some of the largest impediments to wide-scale DAC. One, we operate roughly at ambient temperature and pressure. So most of our system can be built with plastic. It's a big deal. No stainless steel reaction vessels, no difficult to weld metal piping. It's lightweight, and it has a low CO2 footprint, which is critical for gigaton scaling. We only use electricity as an input, and we're highly interruptible. That allows us to use renewable energy. The energy needs of DAC are unfortunately massive. So trying to do a DAC solution that needs 24 by 365 power doesn't scale. We can help stabilize the grid, not destabilize it. Lower energy usage. We use half the energy of the current leaders in this technology. And again, we can use interruptible renewable energy. We isolate the active chemicals from exposure to contaminants in the air. To perform DAC, you have to move massive, massive volumes of air. There's lots of rocks, particularly if you're going to put it in a desert environment, dust, pollutants, pollen, and just crap in billions of cubic feet of air. We stop the direct contact of the dirty air with anything sensitive, particularly our electrochemical membrane, allowing a closed loop in our reactive chemistry. We have a closed mass balance. We don't keep adding anything except electricity, since we've largely eliminated water losses. This creates something that's inherently modular, containerizable design that we think leads to mass production and easy deployment. This matters as we need to build millions of capture units a year to solve the climate crisis. We believe this approach is the only one that can scale and reach the sub $100 a ton goal the US government set for its moonshot target. And we think we can get there as soon as 2025. So what does $100 a ton mean? It means mitigating the climate crisis for less than $1 a gallon of gasoline. We think these advantages are compelling and dramatically different from other approaches, which we'll talk about later. Next slide. So the market, I'm not going to talk about it much. It exists today. It's rapidly growing. There's bipartisan support. And if we're going to make a dent in global warming, it has to become one of the world's largest markets, or we roast. So, but one note, and it's on the slide, $100 a ton, 1 gigaton is $100 billion. 10 gigatons, it's $1 trillion a year. Market's not the issue. Scaling the right technology is the issue. Next slide. So I just want to take a minute about competition, primarily to emphasize again how our approach is slightly different. These are all high-profile companies in the DAC space with recent funding announcements. I also want to step back for a second. When we talk about sequestration and capture of carbon, there's also the side of disposal. Disposal is not a problem. It can be done for about $15 a ton. We've been doing it for 50 years. We've now put billions of dollars toward carbon hubs precisely for this purpose. All the companies in the slide are doing, we're doing, making capture devices. So Verdox, they've created a specialized membrane, claim very, very low energy efficiency, but they have to create millions of square meters of an electrically and chemically active membrane. And that membrane, because you can't put HEPA filters at the front end, all you do is change filters, is going to get directly exposed to everything in the air. I wish them luck. Mission Zero is somewhat similar approach to ours, but we with a different and more complex chemical, active chemical. Climeworks just got $650 million, you've heard about in Iceland. They use steam and vacuum to release CO2 captured on solid absorbents in chambers. So it requires a lot of heat, plus its absorbent is fully exposed to the air. You also can't turn the power on and off when you have heavy heat because you lose a lot of energy, so you can't use uninterruptible power. Carbon engineering has a base to capture CO2 just as we do, but it's exposed to the air, so they have to design to avoid blow-off of a caustic solution. And they have water losses to worry about, and then they do a more complex cycle that, among other things, involves 900 degrees C temperatures. to release the CO2. They have a $900 million plant under construction. It uses natural gas to provide the heat and captures that CO2. And it uses about 3 times the energy we think we need. Heirloom, recent company, very low cost materials, reversing the cement production cycle. They also need 900 C's heat to release the CO2. That's about 2 times the energy we project. So we use low cost materials that exist. We shield our active membranes and we're low energy. Again, we think these advantages will prevail. Next slide. So where are we? One, in the Wang lab, we've got a continuously operating prototype. It's still sub-kilogram a day level. We're expecting some additional pieces that we've ordered to come in to rapidly ramp that up toward a 10 kilogram a day goal by the end of 2022. We're finalizing an IP license agreement with Johns Hopkins. It'll be part of our kickoff for this company. We've been working already with development partners for system components, and we're going to start real system development toward a 1 ton a day plant by the end of 2022 for the development, but we expect to actually put in operation a plant by 2023. We're seeking $1.5 million basically for startup purposes, establish a base of operations, get our first full-time employees outside of sponsored research, which we'll also be doing. We're going to leverage our initial capital with grants from DOE, DARPA, and others for non-dilutive capital, which we already have some interest in. And we're going to position ourselves for a serious seed fundraise by 2023 to implement a real scale. So thank you. Next slide. That's it. With your help, we can save the world and make money at it. We hope you'll join us.
Thank you, Jim. Michael, would you like to start?
Sure. Thanks for a nice presentation, Jim. It's nice to meet you. So my question is just could you describe your strategy for generating early revenue? Like what will the first couple of revenue sources be? Are you imagining carbon removal purchases from companies like Stripe and some of the others doing purchase programs? Or I could imagine maybe this would be applicable to other industrial gas separations. How are you thinking about that?
I'm absolutely not worrying about it. Okay, yes, we'll end up doing the applications we'll work with various organizations. But truly, I've seen other presentations where they have half-baked the technology and spent all their time worrying about the disposal side. Frankly, I think it's nonsense. If you can demonstrate a feasible low-cost solution, especially in the price ranges and the energy ranges we think we can hit, it's game, set, and match. So I'm really, and frankly, if I'm going to sell 1,000 tons at $500 a ton, whoopee-doo. That's not the focus. The focus is the technology development over the next 24 months.
Right.
I really appreciate that presentation, James. I just had 2 questions. One, I was just curious what that predicted energy usage per ton is going to be. And then the second half, do you guys have any geographical limitations on where you can be located?
Right. So yeah, let me go to the second one first. Yeah, a lot of this thinking about the need to do the air contactor and the sort of closed loop cycle is very much sort of thinking through that issue. We do have enough heat generation that we, will have enough side heat to sort of keep this thing operating at fairly low temperatures. We may have issues when you start pushing up into really hot desert environments, during the middle of the day. But we've specifically been thinking about a wide range of stuff, particularly places, assuming the political situation was there, like Algeria, where you have both the sun, but you also have the depleted reservoirs that you can inject the CO2 into. So yeah, a lot of the thinking behind this, what makes it so attractive to me, is the potential robustness of where we can locate this. Sorry, and then you asked the first question was the energy stuff. Right now, we know we're under 4. We think we're at 3.5, and I don't think there's any doubt at all we'll pick up another 20-25%. We'll be under 3 gigajoules a ton. I'd like to hope for 2.5, which you could get in theory, but I'll take anything under 3 in the real world.
3 gigajoules, you said? That's awesome.
Yeah. So that's less than a megawatt hour.
Yeah, that's great. That's great. Thank you.
Sean?
Jim, thanks for an excellent presentation. Can you sort of, if I remember you correctly, you sort of mentioned sub $100 a ton as soon as 2025. Can you sort of walk us through the near-term milestones following sort of 2023, and what has to happen from a financing standpoint, from an adoption standpoint to get there that quickly?
Yeah, I think the electrodialysis stuff, we think we have a pretty good handle on. And that's really a question of just adding units. It's one of those areas where there isn't the dramatic economy of scale by making them, bigger rectangles. You're sort of going to modularize that. So the rest of it is kind of like literally talking about plastic reaction vessels. And that's one of the reasons, when you're dealing with acid and base stuff, you often use plastic pipes anyway. Now, but if I got too hot, then I've got to worry about other things going on. The fact that I think I can do all this in plastic dramatically changes the whole speed and lowers the capital cost and the assembly cost. The other, point obviously is the air contactor. And there, frankly, we've got one group that I've very much been in touch with. It's been working on a design for similar to this purpose of this stuff, using a very obtainable membrane for the last year in their stuff. And we have a meeting. We kind of, under the terms it's Accelerator, we can't quite form the company until we actually incorporate. We couldn't incorporate until we got the company, so I couldn't execute the NDA. We have a major billion-dollar company that has concluded that a lot of their business forward is going to be in the DAC space, and they are very much pursuing this kind of stuff. So I expect the air contactor stuff to be largely done in partnership, and that's going to also reduce it. But yeah, I think we're going to need as little as $10 million to prove out more than sufficient reality at a substantial scale. And again, 100 ton a day is kind of a metaphorical number, and that we haven't finished the detail engineering around a 40-foot container or two 40-foot containers, which is how I suspect it'll be, one with air contactors and one with the balance of the plant.
Got it. That's very helpful. Thank you.
All right, Jim, thank you very much. Great presentation. And we're going to move forward with our introduction of our next sponsor. I'd like to introduce Joe Bishop from the accounting services firm Snyder Cohn. Welcome, Joe.
Thank you, Brian. I appreciate the opportunity, and congratulations again to all the participants. My name is Joe Bishop. I'm a CPA and a manager in the Audit and Accounting Division of Snyder Cohn, a CPA firm in North Bethesda, Maryland. We've also been a sponsor of MEIA since inception, and we serve a wide variety of clients in several industries, but I myself specialize in serving emerging companies and startups in the tech industry, as do a number of professionals at our firm who are all members of our technology team. Cheryl Huser, one of our partners and the leading member of the team, is also here today, and we're both enjoying learning more about your businesses. Cheryl is also a UMD alumni, and we frequently engage with UMD to hold various workshops and presentations on accounting issues for tech companies. We service our technology clients from both a financial statement side and the tax side, helping solve a wide variety of problems and also providing general consulting services as they're needed. We're always excited to work with young clients who have great ideas and are just starting out, and we very much enjoy the process of growing and learning with them. Some of the common issues we frequently help clients with include form of organization, specifically the advantages and disadvantages of forming as either a corporation or as a partnership, federal and Maryland R&D credits, as well as any other tax credits that are potentially available for tech companies, compensation issues, including equity compensation from both a tax and financial statement side, and also bookkeeping issues, including helping you with your chart of accounts and setting up your software, such as QuickBooks or QuickBooks Online. We have an outsourced accounting division that specializes in QuickBooks and can help you set it up and implement it to your needs. With our sponsorship, we're very excited to provide you with up to $5,000 of free services and to assist you with any questions or issues you may have. We've already assisted a number of the teams within MEIA over the years, and we look forward to continuing those relationships and getting to know the rest of you all better. Thank you very much, and good luck.
Thank you, Joe. Now I'd like to introduce Greg Stone from the intellectual property partner from Whiteford Taylor Preston. Welcome, Greg.
Thanks very much, Brian, and it's a pleasure to be here. Actually, this is our first participation at a MEIA pitch event, so really thrilled to be here. Fantastic presentations, and don't know what to say other than good luck to the judges. Trying to discern among the these great candidates is going to be a tough job. I don't envy it, but congratulations to all the folks that are here. So again, I'm Greg Stone. I am a patent and general intellectual property attorney at Whiteford, Taylor & Preston in Baltimore, where I co-chair our technology and intellectual property practice group. Whiteford, Taylor & Preston is about 180 attorney general practice law firm with 17 offices throughout the Mid-Atlantic. But again, my practice is focused entirely on the area of intellectual property. I started my career back in 1992 after a short stint as a mechanical engineer, actually going to work at the Patent and Trademark Office as a patent examiner. So I've been in the patent field since '92, and since I've been an attorney in practice, it's been all things intellectual property. So that's preparation and filing of patent, trademark, copyright applications, developing strategic IP portfolios, doing M&A due diligence, so helping to position companies before a major transaction to ensure that their IP house is in proper order, and then obviously litigating both when folks are popping up with potential infringers on the outside that they're going after, or if they're unfortunately accused of infringement. We work with clients of all shapes and sizes in all technology areas, from early stage startups to Fortune 500 companies. And really over the years since I've been, the 22 years since I've been at Whiteford, we've done a lot of work with different incubators. We've done a lot of work with the startup companies in incubators. And I got to tell you, I was thrilled when I ultimately found MEIA, because I've always had a desire to grow the client base that we have in the clean energy space, particularly, and was surprised that I hadn't previously heard of MEIA. My fault, not theirs. But I'm so glad that I found the team. We've had limited opportunity to work with some folks so far, but we welcome the opportunity to do more of that, and are just incredibly impressed with the great technologies that are coming out of the organization. Greg Stone, Whiteford, Taylor & Preston.
Thank you very much, Greg. All right, it's now time for our audience poll, where you select the most investable startup. Let's imagine that you work in a venture capital firm, and you need to recommend one of these companies for a $500,000 investment. Which startup would you recommend? Sabrina has put the poll on your screen, so I'll give you 20 seconds to make your selection. Okay, Sabrina, let's see who won. We have a tie. Congratulations, ATP-MD and Dynami. Very exciting. All right. So I'm now excited to showcase 3 MEIA alumni companies who will be giving updates on their progress. We'll hear from ActiveCharge, HighT-Tech, and InventWood. Welcome, Pranay Kohli from ActiveCharge.
You may want to skip to Bob.
Okay, let's welcome Bob Gaddy from HighT-Tech.
Thanks, Brian. As Brian mentioned, I'm Bob Gaddy. I'm the CEO of HighT-Tech. We're now in the Accelerator Program, having graduated last year. HighT-Tech was formed in 2018. We're a spinoff from the University of Maryland, the labs of Professor Bing Hu, and from Johns Hopkins, and you might be surprised to learn, from the labs of Professor Chao Wang. We've licensed the IP portfolio from the University of Maryland, including 22 unique invention disclosures. The core technology of the company is we call it ultra high temperature shock. It has multiple applications. These would be in materials manufacture, things like catalysts, especially powders, specialty ceramics, and then also sintering technology for making sintered layers, sintered films, as well as inorganic coatings, as well as others that we're still exploring. And as of today, I'm now going to take a look at sintering and of carbon chars based on the conversation earlier. I started with the company as an EEIR, followed by joining as a CEO last year. So the reason basically I understood the uniqueness of the technology, our initial focus is really in the catalyst market. The technology has earned a couple of science cover articles, 2 R&D 100 awards, and last year we won the spin-off prize from Nature. This was a competition between university spin-offs, global university spin-offs that Nature sponsors annually. In addition, I would be remiss if I didn't thank several of the sponsors of MEIA, besides Brian and Ben, as we've used the services of several of them during the course of the last year. What's happened since we graduated? Well, we've added some new people, new equipment to speed the scale up and proof of concept and joint development opportunities that we're currently investigating. We did win the second R&D 100 award. The first patents were issued and granted and issued last year. Most importantly, however, we generated our first revenue. We sold a proof of concept research project in one of the specific target applications, and we're currently working through to prove that our technology will work for this potential customer and licensee. And then in addition, as of February, we were granted a $3 million award from ARPA-e for a project devoted to the scalable manufacturing of high entropy alloy catalysts for ammonia oxidation. This will be used to demonstrate the first production and to verify commercial performance of our HEA catalyst systems. So we continue to grow, we continue to gain momentum, and we have a lot that we owe to MEIA and their sponsors to helping us along that path.
Thank you, Bob. Great to hear from you. Let's welcome Josh Cable from InventWood.
All right. Well, hello, everyone. Very exciting session today, and congrats to all of the teams. I know what it's like to be in the hot seat, and you all did tremendously well. For those of you who may not know us, InventWood is an innovator of advanced wood materials. We're like wood alchemists in that we're able to transform the chemistry of wood to imbue it with incredible properties. And with the support of MEIA, we've made incredible progress, including securing a seed funding round of about $3 million. We won 2 big contests, one at Greentown Labs and a $50,000 award from the CUPtech Rocket Fund that we actually just found out about. And we're now partnering with a large multinational client to bring a new construction product to market. I jokingly say that InventWood has plans to take over the world one cellulose molecule at a time. And with that in mind, we have some very big plans for our future. By the end of the year, we will have doubled the size of our team from 5 to 10 employees. We'll be moving into a much bigger facility in the College Park area. And most tangibly, we are focused on scaling up our production with a pilot facility that will be able to produce 1 million square feet per year of our metal wood product. I want to say a big thank you to Brian, Ben, the broader MCEC team, and all of the sponsors for all of your support. Brian and Ben in particular, I really appreciate all of your support and guidance, even in the times where I wasn't really receptive to hearing it. It's been a great journey, and it was a bittersweet graduation. For all the teams today, you're in very good hands, and please reach out if I can be of any service. Thanks very much. Brian, back to you.
Thank you, Josh. Very kind words. Renee from ACTIVECHARGE, are you on?
Yes, give me half a minute. Yes, I'm here.
Great, I can see you.
Okay. Why can't it be big one? Okay, share screen. Okay, I think the previous screen has to be unshared and then I can share it.
Can you just speak to whatever you'd like to say today? We only have a couple minutes.
Okay. So from our perspective, I think we have had interesting journey since our last when we were here, and it has been made very interesting by COVID because we lost access to our lab for about 2 years, and only now this academic year we have been able to get something back. And I'm pleased to say that we got the award from Maryland MIPS award, the first phase, which we are working on. And I'm also pleased to say that last week we also got the DOE SBIR award as well. And we also participated in several industry events, especially with the whole of Wind Energy Consortium in Atlantic City, New Jersey. We met lots of different players, and it has been very, very encouraging for us to meet all of them. We are looking forward to producing our next iteration of our product and the software. And now we actually have a wind turbine with broken wings, basically, to test our product in our lab at University of Maryland. So I'll stop here. I think there was some confusion on my part, but thanks for letting me know and letting me speak. Thanks.
Thank you, Pranay. Great to see you. Before we announce the judge's decision, winner of our $1,000 prize, Ben and I want to thank the Maryland Clean Energy Center Executive Director, Kathy Magruder, and MCEC Communications Director, Sabrina Bachman, for their continued support. We also want to thank the Maryland Clean Energy Center Board of Directors for its support. Additionally, we want to thank the MEIA Advisory Committee members, Eric Waxman from University of Maryland, Alex Pavlek from Future of Energy Initiative, and Al Dalia from Frostburg State University. My last bit of housekeeping for today: when you disconnect, you'll be asked a quick 2-question survey. Please take a moment to give us feedback about today's event. Now is the moment we've all been waiting for. I'd like to introduce Wade Harley from the Maryland Department of Commerce, who will now present the $1,000 prize to the judge's selection. Welcome, Wade.
I am honored to represent Secretary Mike Gill and the entire team here at the Maryland Department of Commerce. We are the premier economic development agency. We stimulate private investment, create jobs by attracting new businesses, encourage expansion and retention of existing businesses, provide workforce training and financial assistance to Maryland companies. The department also promotes the state's many economic development advantages in the market, and we market local products and services at home and abroad to spur economic development and international investment, trade, and tourism. I'm in the Office of Strategic Industries and Entrepreneurship, and I work to support and attract and expand businesses. Our group works in life sciences, cybersecurity, aerospace, manufacturing, agribusiness and energy, entrepreneurship, and education and workforce. I am the Energy and Agribusiness Program Manager, and I also do some efforts in recycling. So I put my contact information in the chat. I am glad I am not a judge today, but every one of you that presented today, if you need help with the state of Maryland, please contact me and I will find the right people for you to work with. And I will stop at that, but we at the Department of Commerce are honored to announce today's winner, EDECA Labs.
All right, congratulations to EDAC Labs. And this concludes our 2022 pitch competition. Thank you all for joining us, and we'll see you next year.